Cold open, the security story is no longer just that criminals exploit software. The new pattern is that criminals exploit trust shortcuts. A business trusts a legacy enterprise application because it has been running for years. A developer trusts a package because an AI assistant opened it inside a workflow. A consumer trusts a CAPTCHA because it looks like every other verification screen. A platform trusts a support automation flow because it is supposed to reduce friction. Today's question is simple: what changes when automation moves faster than verification? Here is the central thesis for this episode of Daily Tech Hack Global. AI agents, cloud platforms, and security tools are becoming part of the same risk surface. That does not mean AI is the villain in every story. It means that every automated decision, every recovery flow, every package inspection, and every familiar prompt has to be treated as a security boundary. If teams keep the old assumption that a human will pause before something dangerous happens, attackers will route around that assumption. Start with the enterprise side. Ars Technica reported that a zero-day affecting Oracle-owned PeopleSoft was used to steal gigabytes of data and may affect hundreds of organizations. The article describes the vulnerability as about as critical as enterprise software gets. PeopleSoft is not a flashy consumer app. It is the kind of software that often touches human resources, finance, identity data, procurement, and internal business processes. That is why the blast radius matters. A compromise in a system like this is not only a technical incident. It can become an employee privacy incident, a supplier risk incident, a legal incident, and a board-level trust incident. The safe technical explanation is this: enterprise platforms concentrate permissions and data. If an attacker finds a path into one of those systems, the value is not just the server itself. The value is the data connected to workflows, integrations, and accounts. For defenders, the lesson is not to wait for a perfect headline or a complete public postmortem. Inventory the exposed PeopleSoft footprint. Confirm vendor guidance through official channels. Review logs for suspicious access and unusual data movement. Prioritize systems that are internet-facing or connected to sensitive records. And assume that business owners, not only security teams, need to understand what kind of data may have been touched. Now connect that to the software supply chain. Ars Technica also reported that 73 packages in Microsoft package ecosystems ran a self-replicating credential stealer as soon as they were opened by an AI agent. The report said this was the second similar incident in weeks. That detail matters because it points to a shift in attacker expectations. Criminals are no longer designing every malicious package only for a human developer who manually installs it. They are also anticipating automated tooling, code assistants, dependency scanners, build helpers, and agents that inspect repositories on behalf of developers. This is one of the clearest AI security crossovers of the week. Agentic tools can move through code, dependencies, and documentation at machine speed. That is powerful when the agent is summarizing a repository or helping a developer fix a bug. But if the agent opens untrusted packages in an environment with tokens, network access, or file system permissions, the agent becomes a bridge between untrusted code and valuable credentials. The defensive answer is not to abandon AI development tools. It is to sandbox them. Untrusted packages should be inspected in restricted environments. Agents should not inherit production credentials by default. Package execution should require clear policy gates. Logs should show what the agent touched, what network calls happened, and which secrets were available. This also changes how leaders should evaluate productivity claims. If an agent saves 10 minutes but runs untrusted material with access to cloud keys, the real cost may be invisible until an incident. The better metric is not raw speed. The better metric is verified speed. How quickly can the team move while maintaining isolation, provenance, and repeatable checks? That is the future of developer security. AI will accelerate the workflow, and security has to accelerate the guardrails without turning into noise. For everyday users, the same trust problem appears in a much simpler form. The FTC warned about fake CAPTCHA prompts. The agency said it is receiving reports about phishing pages that look like ordinary verification checks. Real CAPTCHAs ask image or text-based questions to prove that you are not a robot. The fake versions ask people to take local device actions. Those actions may paste and run hidden malware. The key point is easy to remember: a real CAPTCHA does not ask you to run commands, open system tools, install software, or approve a download. Why does that scam work? Because people are trained to expect friction online. We click cookie banners, solve image puzzles, approve sign-in prompts, and dismiss security warnings all day. Attackers turn that habit into a script. They do not need to break strong encryption if they can convince the user that a dangerous local action is just one more verification step. So the first 10 seconds matter. If a page says you must copy a command, press a keyboard sequence, run a terminal command, or download a helper to prove you are human, close it and navigate away. If you already clicked, the FTC recommends disconnecting from the internet, scanning the device, updating software, changing important passwords from another device, turning on two-factor authentication, and reporting fraud. Now here is the constructive part. AI is not only creating new risk. GitHub published that it is using context-aware LLM reasoning to make secret scanning more trustworthy by reducing false positives at scale. In plain language, secret scanning tries to catch exposed tokens, keys, and credentials before attackers find them. But if the tool floods developers with too many false alarms, people ignore it. GitHub's argument is that language models can help the verification step by understanding more context around whether an alert is actionable. That is the kind of AI security use case that matters. The goal is not to replace security judgment with a magic model. The goal is to reduce noise so humans can respond faster to real risk. The caution is also important. If an AI system suppresses too much, it could hide a true positive. If it explains too little, teams cannot audit its decisions. The winning pattern is AI-assisted triage with transparency, show the reason, preserve the evidence, allow review, and measure outcomes. Used well, LLMs can make security operations less exhausting. Used carelessly, they can become another black box that teams trust without verification. The final story is about identity recovery. Krebs on Security reported that hackers abused Meta's AI support assistant Flow during Instagram account takeovers, with high-profile accounts briefly defaced after instructions circulated online. The report said Meta fixed the issue. We are not going into operational details. The defensive lesson is enough: support bots are no longer just customer service widgets. If a bot can influence password reset, account recovery, or email changes, it is part of identity infrastructure. That means it deserves identity-grade controls. Recovery flows should require strong signals, rate limits, audit trails, and human escalation for unusual cases. Changes to recovery email addresses and phone numbers should create clear alerts. High-profile and business accounts should have stronger recovery policies than ordinary low-risk accounts. And AI support systems should be tested by red teams that think like attackers, not only by product teams checking whether the conversation sounds helpful. Put the 5 stories together and the pattern becomes clear. PeopleSoft shows what happens when trusted enterprise platforms become data theft targets. Package malware aimed at AI agents shows that developer automation must be isolated. Fake CAPTCHAs show that familiar verification screens can become social engineering. GitHub secret scanning work shows that AI can reduce security noise when deployed with accountability. The Meta support bot report shows that automation in identity workflows needs adversarial design. So what should defenders change this week? First, separate untrusted code from credentials. If an agent, scanner, or build process touches untrusted packages, run it in a sandbox with minimal access. Second, treat recovery flows as high-risk events. Password resets, new recovery emails, token creation, and privilege changes should be logged, alerted, and easy to reverse. Third, reduce alert fatigue without hiding evidence. AI triage should explain why it thinks an alert is low or high confidence. Fourth, train users on the simple fake CAPTCHA rule: verification proves humanity, it does not require local commands. Fifth, make enterprise patching a business process, not only an IT process, because the data at stake often belongs to employees, customers, and partners. The payoff is this: the next security advantage will belong to teams that can automate safely. They will use AI agents, but inside compartments. They will use LLMs, but with review and evidence. They will move fast, but not by giving every tool the keys to production. They will design support flows that help real users without letting attackers turn convenience into account takeover. What should you watch next? Watch for more attacks that are written specifically for AI-assisted workflows. Watch for vendors to add stronger sandboxing and provenance features around agents. Watch for cloud and enterprise platforms to emphasize identity telemetry around recovery events. And watch for consumer scams that disguise themselves as normal security checks. The question is no longer whether automation belongs in security and development. It already does. The question is whether we can make verification just as fast as automation.